Hello, we are starting with exercise 5A of compound angle formulae. Okay, so let us first list down the compound angle formulae. Sine A plus B is equal to sine A cos B plus cos A sine B. Okay, see, you cannot do sine A plus B as sine A plus sine B. This is absolutely wrong. Okay, so by the rules of trigonometry, this is not quite applicable. Okay, then sine A minus B, this is equal to sine A cos B minus cos A sin B. Then cos A plus B, cos A cos B minus sin A sin B, and cos A minus B is equal to cos A cos B plus sin A sin B. Okay, right? Now for tan A plus B is equal to tan A plus tan B upon 1 minus tan A tan B and tan A minus B. This also formula you should remember. Okay, tan A minus B is equal to tan A minus tan B upon 1 plus tan A tan B. Right? Okay, so let us start with the exercise 5A. Question number the question. So if you are reading the problem, I'm sure you are having the textbook in front of you. They are asking you sine 15 from the functions of 60 and 45. So sine 15, which is equal to sine, you have to involve 60 and 45 degree. Those are standard angles. So you can also write 45 minus 30. Those are also standard angles, but then they are asking you to take 60 and 15, 60 and 45. So this is A, this is B. Okay, so let 60 be A, 45 be B, that you can write. So this is equal to sine A cos B minus cos A sine B. Okay, see, you can write this on your own, like I'll not write this again and again, but then to assume this as 60 and 45 directly also you can do. Okay, not a problem. Yeah, so sine 60 cos 45 minus cos 60 sine 45. Put the values. Okay, you can put the values. I'll take a new page for this. Okay, so the first value sine 60 is root 3 by 2, cos 45 is 1 by root 2. So root 3 by 2, 1 by root 2. Okay, then cos 60 is half and sine 45 is 1 by root 2. So half into 1 by root 2. Okay, so if you take LCM and solve it further, you'll get the answer. Root 3 minus 1 upon 2 root 2. Now, if your school teacher is asking you to rationalize numerator, then rationalize numerator. If she's asking you to rationalize denominator, then rationalize the denominator, so on and so forth. Okay, yeah. So next problem, they're asking you to find out the value of cos 45, 345. Okay, using the functions of 345. Okay, making use of 345. So 300 plus 45. Okay, is 345. So this is A, this is B. So cos A, cos B minus sin A, sin B. This, sorry, put the values of A and B. Cos 300, cos 45 minus sin 300, sin 45. Okay. Then cos 300, sin 300, this values will calculate. Now cos 45 is 1 by root 2, sin 45 is 1 by root 2, this value we have written. Now I'll show you how to calculate cos 300, okay? Cos 300 is equal to cos, divide 300 by 90. 90, 3s are 270. Okay, so the remainder is 30. So 3 into 90 plus 30. Okay, quotient into divisor plus remainder. Dividend is equal to quotient into divisor plus remainder. Now 3 pi by 2 plus 30. This is 0 pi by 2, 1 pi by 2, 2 pi by 2, 3 pi by 2. So 3 pi by 2 is over here. Plus, there is plus sign which indicates anti-clockwise direction. So in this particular quadrant, we'll check out for cos. Cos is positive. Okay, and 3 pi by 2 lies on y-axis. So cos changes to sine. Sine 30, which is equal to half. So we got the value of cos 300. Cos 300 is half. Okay, now we'll calculate the value of sine 300. So sine 300, initial part remains same. 3 into 90 plus 30. So 3 into pi by 2 plus 30. The diagram, arrow diagram, same. Okay, so in this quadrant, okay, your sign is negative, fourth quadrant, right? And y-axis, and on y-axis sign changes to cos, so it is cos 30. So this is minus root 3 by 2. Okay, so let's put this values half and minus root 3 by 2 over here. So 1 upon 2 root 2 plus root 3 upon 2 root 2, which is equal to root 3 plus 1 upon 2 root 2. Okay, the minus minus I have taken it as plus, right? Okay, now if your teacher is asking you to take sine cos 300 sine 300 from the calculator, you can do that. Otherwise, whatever I've taught you, you apply that. Okay, but then you should know this: 0, 30, 45, 60, 90, 180. These are the standard angles. This value you should know. Also remember, sine 180 is 0 and cos 180 is -1. Always remember that. Fine. Yeah. So let us go to the third sub question. They are asking you the value of tan 105. Tan 105 is equal to tan 40 plus 45 plus 60. They are asking you to find out tan 105 from 45 and 60. Okay. So this is A, this is B. So this will be tan A plus tan B, 1 minus tan A tan B. Okay. Right. Yeah. So tan 45, A is 45, B is 60, 1 minus tan 45, tan 60. Put the values. Tan 60 is root 3, 1 minus 1 into root 3, which is root 3 plus 1 upon 1 minus root 3. That is the answer. Okay. In the numerator, you can also write 1 plus root 3. That's not a problem. Fine. Yeah. So sixth and fourth and fifth sub question, you can do it on your own. Similar way. Let us go to the sixth one. Okay. Fourth sub question, 180 degrees is the one of the angles. So you need to know what is sine 180, cos 180. And fifth sub question, if by any chance it is sine 150 and cos 150, what you need to do is you need to divide by 90, use the divide by 90 method. Okay. Yeah. Let us go to the sixth one. Okay. So this is cosec 13 pi by 12. Okay. So this is cosec 13 into 180 by 12. We are converting into it this into degrees. So this is equal to cosec. Okay. You have to calculate this. Fine. You can reduce it or use a calculator also, not a problem. It is 195. I solved it in the, I got 195. Okay, but then now which trigonometric functions we are supposed to take? They have not given. Uh, so I think sine, cos, and tan is a better option. Always convert your problem into sine, cos, and tan. So this is sine 1 upon sine 195. Okay, which is 1 upon sine 195 you divided by, you know, um 90 divided by 90 method. So sine 2 into 90 plus 15, which is 1 upon sine 2 pi by 2 plus 15. Okay, now see 0, 1, 2. So 2 pi by 2 is over here. Plus indicates anti-clockwise direction. So in this particular quadrant, okay, your sign is negative. Okay, sign is negative, and 2 pi by 2 is on the x-axis. So sign remains sine 15. Now 15 is not a standard angle. So I'll write this as minus 1 upon sine 15. Now sine 15 can be written as sine 45 minus 30 or 60 minus 45. I'll go ahead with 45 minus 30. So minus 1 upon sine 45 minus 30. Okay, this is A, this is B. Okay, minus 1 upon sine A cos B minus cos A sine B. Minus 1 upon sine 45 cos 30 minus cos 45 sine 30. Okay, so this is equal to minus 1 upon, let's put the values. Okay, sine 45 cos 45 is 1 by root 2. Fine. And cos 30 and sine 30. This value is also root 3 by 2 and half. Fine. So this is minus 1 upon root 3 minus 1 upon 2 root 2. Now this 2 root 2 will go up. So this will be minus 2 root 2 upon root 3 minus 1. Now you can rationalize numerator or denominator or both. That depends on your school teacher, whatever she says, he or she. Yeah. Let us go to question number 2. Fine. So question number 2 says simplify in the as a single term. So first one is sine 3 alpha cos 2 alpha plus cos 3 alpha sine 2 alpha. So this is A, this is B, this is A, this is B. Okay. Let 3 alpha be A. Okay, I'll write that way, sorry. Let 3 alpha be A, 2 alpha be B. Okay. So this can be written as sine A cos B plus cos A sine B. So this is sine A plus B as per compound angle, which is sine. Put the values of A and B. So this is sine phi alpha. Okay. So second, third, fourth, you can do it on your own. I'll go ahead with the fifth sub question. This was the first one. Assume it to be A and B so that you know there is no error anywhere. There won't be any error anywhere. Second one, the question is, sorry, the fifth one. I'll be solving the fifth one right now. Second, third, fourth, you can try it on your own. So sine x minus y cos x minus cos x minus y sin x. Okay. So let x minus y be A and x be B. Okay. So this can be written as sin A. Okay. And cos A minus cos A into sin A. Fine. So this is equal to sin A minus B. Now put the values of A and B. A is x minus y and B is x. Open the bracket. Go systematically so that there are no errors. So the answer is sin of minus y. Sin of minus y is minus sin. Okay. Yes. Then let's proceed with question number 6. Okay. Cos theta plus alpha, cos theta minus alpha minus sin theta plus alpha, sin theta minus alpha. Okay. So let theta plus alpha be A, theta minus alpha be B. So this equal to cos A cos B minus sin A sin B, which is equal to cos A plus B. Cos A, what is A? Theta plus alpha. And what is B? Theta minus alpha. So if you open the bracket, it will be theta plus alpha minus theta plus alpha. Okay. So this will be cos 2 alpha. Okay. Go very systematically so that no errors occur anywhere. Let's go to question number 7. Tan 69 plus tan 66 upon 1 minus tan 69 into tan 66. Okay. So A, let it be 69, B, let it be 66. Okay. So this is equal to tan A plus tan B, 1 minus tan A tan B, which is equal to tan A plus B, the compound angle formula, in a reverse way. In the reverse way. 69 plus 66. So 69 plus 66 is 135. Okay. Now divide 135 with 90. 90 ones are 90. So this is 45. So 1 into 90 plus 45. So that will be 10, 1 pi by 2 plus 45. Now let us understand what is 1 pi by 2. This is 0 and this is 1. That's 1 pi by 2. Plus is anti-clockwise. In this quadrant, your tan is negative. Okay. Tan is negative over here. And 1 pi by 2 is y-axis. Tan changes to cot. Cot 45 is 1. So the answer becomes minus 1. Okay. Question number 8. Tan alpha minus tan alpha minus beta upon 1 plus tan alpha into tan alpha minus beta. Okay. So let A be alpha and let B be alpha minus beta. Okay. So this is equal to tan A minus tan B upon 1 plus tan A tan B. So tan A is equal to tan A minus tan B upon 1 plus tan A tan B is tan A minus B. Put the value of A and B. A is alpha and B is beta. Put the brackets because there is a minus sign in between. Open the brackets. Tan alpha minus alpha plus beta. So the answer becomes tan beta. Okay. That was your question number 2. Let us proceed with question number 3. Okay. Sin alpha cos beta plus cos alpha sin beta the whole square. Okay. plus cos alpha cos beta plus, sorry, minus sin alpha sin beta, the whole square equal to 1. This is what we need to prove. So I'll start with LHS. Okay, I'll start with LHS. We'll prove it to be 1. Now see, look at this underlined part. I'll just put the square outside. Sin alpha cos beta plus cos alpha sin beta is sin alpha plus beta. And cos alpha cos beta minus sin alpha sin beta is cos alpha plus beta. Okay, let alpha plus beta be theta. Let it be theta. Okay, so sin theta the whole square plus cos theta the whole square, which is equal to sin square theta plus cos square theta, which is equal to 1, and that is equal to your RHS. That was the solution for question number 3. Okay, let us go to question number 5. Oh, sorry, 4. Question number 4 I will solve. You can take question number 5 for your self study. Okay, so question number 4. Okay, so I'll take the LHS sin 60 plus theta minus sin 60 minus theta. Okay, now see, RHS is sin theta. Okay, we need to prove the answer to be sin theta. Now I'll put two boxes. Always place as many box brackets as you want so that uh, calculations will be smooth. Okay, don't take too many shortcuts. So this is A and this is B. So sin A plus B is sin A, sin A cos B plus cos A sin B. And this is A and this is B. So it is sin A cos B minus cos A sin B. So we have applied those formula. Open the bracket. Sin 60 cos theta plus cos 60 sin theta minus sin 60 cos theta plus this minus into this minus is plus cos 60 sin theta. Okay, so this and this term is getting cancelled. So this will be twice cos 60 sin theta. Now cos 60 is half. Okay, 2.5 will get cancelled. So the answer is sin theta, which is your RHS. So you can try question number 5 on your own. It is in the similar manner. Okay, 5 as well as 7 I'm giving you for self study. Similar manner, not a very complicated one. So you can start with the LHS, you can complete the RHS. Get your RHS. Okay, by simplifying. Compound angle formula is to be used in question number 5 and 7. Let us question number 6. Okay, so we have to prove sin 240 plus theta plus cos 330 plus theta. Okay, cos 330 plus theta equal to 0. This we need to prove, right? So first I'll start with the LHS, but then I'll solve one term at a time. Okay, so this is sin 240. This is A and B. So I'm using sin A plus B formula. Sin A cos B plus cos A sin B. Okay, so this values will just calculate sin 240 cos 240. Okay, so let us start with that calculation. Sin 240 divided by 90, 240, 90, 92 is 180. So this is 60. Sin 2 into 90 plus 60, 2 into pi by 2 plus 60. Okay, now 2 pi by 2. So this is 0, 1 and 2. 2 pi by 2 lies over here plus is the anti-clockwise direction over here. In this particular quadrant, your sign is negative, and 2 pi by 2 is on the x-axis. So sign remains sign. So minus sin 60, which is minus root 3 by 2. So the answer is minus root 3 by 2 over here. Cos theta, cos 240. So cos 240, same calculation because the angle is same. 2 into 90 plus 60. 2 pi by 2 plus 60. 0, 1, 2. The diagram also will remain the same. Plus anti-clockwise direction. In this quadrant, your cos is negative. Okay. And 2 pi by 2 lies on the x-axis. So cos remains cos. So this will be cos 60, which is equal to minus half. Okay. So this is minus half cos theta. So this will be minus root 2 cos theta minus half cos theta. Okay. Now I'll calculate this. I have calculated. I'll calculate this now. Cos 330 plus theta. This is A and this is B. So cos A, cos B minus sin A, sin B. Okay. So now cos 330 and sin 330 values will calculate. So cos 330. Okay. 330 divided by 90. 93 is a 270. So this is 60. So this is equal to cos 3 into 90 plus 60. Cos 3 pi by 2 plus 60. 3 pi by 2. 0, 1, 2, 3. 3 pi by 2 is over here. Plus. Plus is anti-clockwise. In this particular quadrant, your cos is positive, and 3 pi by 2 lies on the y-axis. Okay. So cos changes to sin. Sin 60, which is equal to root 3 by 2. Okay. Now sin 330. Sin 3 into 90 plus 60. Sin 3 pi by 2 plus 60. Okay. So in this particular quadrant, the diagram remains same. Sin is negative, and 3 pi by 2 is y-axis. Sin changes to cos. Minus cos 60, which is minus half. Okay. So root 3 by 2 and minus half. Root 3 by 2, and this is minus half. Okay. So root 3 by 2 cos theta plus half sin theta. Now LHS, we got both the values. Okay, we got both the values. The first value is root 3 by 2 cos theta minus half cos theta. I think I have applied the formula wrong over here. 1 second, let me check. Sin A cos B plus cos A sin B. I'm really sorry for this. This should be sin B. Okay, and this is also sin theta. Okay, so root 3 by 2 cos theta minus half sin theta. Okay, yeah, and this is also minus. So just put that minus. Excuse me for this. And the second value is over here. Root 3 by 2 cos theta plus half sin theta. Now see, the terms are getting cancelled. This and this, one negative and one positive. This also negative and positive. So this is 0 and that is your RHS. Okay. Yeah. Question number 8. I'll just give you the hint. Question number 8. Convert that pi by 3 into degrees. So pi by 3 is 60 degrees. So you can start your LHS with cos 60 plus x. So this is A and this is B. Cos 60 plus S. Fine. Yeah. So you can apply the compound angle formula over here and get the RHS. It's not a very difficult one. Do question one. 9 sub question 1. Okay. LHS is equal to tan 45 plus theta and RHS is equal to 1 minus tan theta upon 1 plus tan theta, as you can see in your textbook. So this is A and this is B. So this is equal to tan 45 plus tan theta 1 minus tan 45 tan theta, tan A plus tan B upon 1 minus tan A tan B. So 1 plus tan theta, you can write the formula property whatever you're applying in the test or in the exam. 1 plus tan theta 1 minus tan theta, that is equal to your RHS. Fine. Question number 10, sub question 2 will do. 9 sub question 2 you can write on your own. So here the LHS is sine theta minus phi upon sine theta sine phi. So let this be A and let this be B in the numerator. Okay, assume it to be A and B. So sine A cos B, I'm directly writing, minus cos A sine B upon sine theta sine phi. Now split this, sine theta cos phi upon sine theta sine phi minus cos theta sine phi upon sine theta sine phi. Similar terms will get cancelled. Okay, cos upon sine is cot phi minus cos upon sine is cot. So it is cot theta. Okay, that is equal to your RHS for question number 10 of question 2. Question number 10 of question 1 you can try it at home. Okay, let's go to question number 11. So we need to prove this sin A minus B upon sin A sin B plus sin B minus C upon sin B sin C plus sin C minus A upon sin C sin A equal to 0. So for the LHS, I'll just first take the first term, sin A minus B upon sin A. So in the numerator, apply that formula compound angle sin A cos B minus cos A sin B upon sin A sin B. Now split sin A cos B upon sin A sin B minus cos A sin B upon sin A sin B. So this is getting cancelled. Cos upon sin is cot, cos upon sin is cot. So this will be cot B minus cot A. Okay. So the first term is cot B minus cot A. Okay. So I'll just write this as cot B minus cot A. Okay. Now similarly, we can calculate the other terms and you can either calculate it or you can also write similarly, whatever your teacher is good with. Okay. So the second term, sin B minus C upon sin B sin C. Understand the pattern. See, sine A minus B upon sine A sine B, we get cot B minus cot A. So this will be cot C minus cot A. The next angle comes first. And sine C minus A upon sine C sine A will give you, okay, see, B comes first and A comes next. So this will be cot A minus cot C. Okay. Yeah. So all the three terms are ready. Put it in LHS, left hand side, because we have calculated individually the value of all three terms. So cot B minus cot A plus cot C minus cot A plus cot A minus cot C. All terms are getting cancelled. I think this should be B. Okay, sorry. The next angle first and this will be next. First will be next. Okay. So sorry for that. Chord B and chord B is also getting cancelled. Okay. And finally the answer is 0. Okay. You can write these two terms as similarly or you can entirely solve it. Question number 12. I'm not solving entirely. I'll give you the hint for question number 12. Okay. Sine 105. Step one, number one, you can calculate sine 60 plus 45. Okay. You'll get some value over here. By sine A plus B formula, you can do this. Okay. And then cos 105. Similarly, you can do that. Take some standard angles. Okay. Don't write 100 plus 5. 100 is also not a standard angle and 5 is not a standard angle. So solve this using cos A cos B, cos A plus B formula. That is cos A cos B minus sin A sin B. Get both the answers and put it in LHS. And check what you're getting. After simplification, you should get 1 by root 2. These two values should add up to 1 by root 2 because 1 by root 2 is cos 45 and that is equal to your RHS. So I've given you the hint of question number 12. Okay. So let us go to question number 13, sub question 2. Yeah. Reading the problem is very important over here. Sin alpha plus beta, cos alpha plus beta, tan alpha plus beta is required. Second sub question says cos alpha is equal to minus 12 by 13 and cot beta is equal to 24 by 7. Okay. Now see, alpha is in quadrant number 2. Alpha is in second quadrant and beta is in third quadrant. We are not assuming, they are mentioning in the problem. So we'll do this triangle method. This is alpha. Okay. Now cos alpha. This is adjacent. 12 is adjacent and 13 is the hypotenuse. 13 and this is 12. So by Pythagoras theorem, the third side will be, the opposite side to alpha will be 5. Okay. So this is by Pythagoras theorem. Fine. Okay. So calculate the value of sin alpha. Sin alpha will be opposite of hypotenuse. Okay. But then it will be positive because we are in the third quadrant. Also calculate tan alpha. Let's see whether it is required elsewhere or not. But sin, cos and tan should be always ready. So tan alpha is equal to opposite upon adjacent. This is opposite to alpha is 5, adjacent is 12. But then tan will be negative because it is a second term. Okay. Now cot beta is 24 by 7. So tan beta is 7 by 24. Cot and tan are reciprocals of each other. Tan will be positive because it's a third quadrant. So this is beta. 7 is opposite and 24 is adjacent. So by Pythagoras theorem, this will be 25. Okay. Hypotenuse will be 25. So sin beta is equal to opposite upon hypo, that is 25, opposite side to beta is 7. So this will be negative. Cos beta is also negative, sin and cos will be negative because it is the third quadrant. 24 upon 25, adjacent upon hypo. Okay. I will start with calculation of individual values, sin alpha plus beta. Okay, which is sin alpha, cos beta, cos alpha, sin beta. We'll put the values. Sin alpha, cos beta. So sin alpha, just a second, sorry. Um, Sin alpha is 5 by 13, cos beta is minus 24 by 25. 5 by 13 minus 24 by 25. And cos alpha sin beta. Cos alpha is minus 12 by 13. Sin beta is minus 7 by 25. Okay, minus 12 by 13, minus 7 by 25. These are the values. Okay, we have a common denominator over here. 13 into 25. So this is minus 120 and this is plus 84. Okay, so 120 minus 84. That that is equal to 36. So minus 36 upon 13 into 25. 13 into 25 into 325. So this time plus, okay, minus 36 upon 325. Similarly, you can calculate cos alpha plus beta. I'll give you the hint. So this is cos A plus B formula. Cos alpha cos beta minus sin alpha sin beta. Now you can calculate, you do this for self-study, you can do this, you have all the values ready. Now tan alpha plus beta, there are two methods. You can either use compound angle formula, that is tan alpha plus tan beta upon 1 minus tan alpha tan beta. Otherwise, you can also use sin alpha plus beta upon cos alpha plus beta, because these two values we have already calculated. Okay, right? So that's it. I think this problem is discussed. So 13 and 14 problems involves problems like this, which we have solved right now. Okay. Let us go to some other problems we'll solve. I'll just break the order in which we are going right now. Okay. So let us go to question number 23. Fine. So we are continuing with this problem of exercise 5A, but then we'll be taking question number 23 right now. Okay. So cos 17 plus cos plus sin 17 is equal to upon cos 17 minus sin 17 equal to tan 62. This is what we need to prove. Now there is a relation between 17 and 62, because when we subtract 17 from 62 we get 45, and 45 is the standard angle. So we have to approach this problem using a different method. So let 45 plus 17 is equal to, let no, we already know this, we cannot assume it's a known fact, sorry. Now 45 plus 15 is equal to, plus 17 is equal to 62, taking tan on both the sides. Tan 45 plus tan 17 is equal to tan 62. Tan 45 plus 17, not tan 17, sorry. So this is A, this is B. So tan A plus tan B, 1 minus tan A, tan B is equal to tan 62. Now two things I will do. Right hand side, see, we already have got, so I'm not going to touch this particular part. Left hand side, tan 45 I'll take it as 1, and at the same time tan 17 I'll write it as sin 17 upon cos 17. So two things, okay. So 1 plus sin 17 upon cos 17, 1 minus 1 into sin 17 upon cos 17 is equal to tan 62. Cos 17 over here and cos 17 over here. So cos 17, I'm taking LCM, I mean, upon cos 17. And down also. Cos 17 minus sin 17 upon cos 17. Okay. We can cancel cos 17. So this is how I've proved it. Fine. So that was question number 23. We got whatever is required. See. Okay. So question number 24 and 25, I'll give you the hints. In question number 24, your starting point should be 2a plus 3a is equal to a. 2a plus a is equal to 3a. Sorry. Now you can take tan on both the sides and solve. Solve and simplify. Left hand side, you can apply compound angle formula of tan. Right hand side, keep it as it is, tan 3a. And no need to convert into sine and cos because the entire problem is in terms of tan. 25. Look at question number 25. 75, 30. These are the angles. So how 75 and 30 are related? 30 plus 45 is equal to 75. So take tan on both the sides and you can solve this. And while solving, you have to keep tan 30 as tan 30 only. Tan 75 is tan 75 only, but then tan 45, write it as 1 because there is no 45-degree mentioned in the problem. Fine. So tan 45, make it 1. So 30 plus 45 is equal to 75. Take tan on both the sides. Fine. Okay. Question number 28. Again, I'll give you a hint. Question number 28 is also a is equal to b plus c. So you can take tan on both the sides and solve and simplify. Okay. Question number 29. Same thing. Same thing. You have to take. They have given a plus b is equal to 45. This is given to us. Take tan on both the sides and simplify. Okay. I'll solve question number 31 right now. Okay. So question number 31. They have given a plus b is equal to 225. And we need to prove something in terms of tan c. Therefore, tan a plus tan b is equal to 1 minus tan a tan b. This is what we are supposed to prove. So hence I'm taking tan on both the sides. Tan a plus b is equal to tan 225. Tan a plus tan b upon 1 minus tan a tan b. So 225, 92 is 180. This is 45. So tan 225 can be written as tan 2 into 90 plus 45, which is equal to tan 2 pi by 2 plus 45. Now 2 pi by 2, 0, 1 and 2. 2 pi by 2 is over here. Plus is anti-clockwise. This according to your tan is positive. Okay. And 2 pi by 2 is on x-axis, so tan remains tan. So this is tan 45. So the answer of tan 225 is equal to 1. So I'm replacing tan 225 by 1. Now you can take this term on the right hand side. Just shift this term on the right hand side. You'll be ready with your problem statement, whatever you're supposed to prove. Okay. So after cross multiplication, you'll get the proof. I hope you understood this. Okay. So let's go to question number 30. Question number 30, sub question 1. Again, I'll read it for you. Use the expression of tan a minus b to find tan 15, leaving your denominator in integer. Integral denominator means integer. Okay. They're asking you tan 15 using tan a minus b. So I can write 15 as 45 minus 30 or 60 minus 45. I'll just write 60 minus 45. Okay. So tan a minus b. So tan a minus tan b upon 1 minus tan a tan b. Tan 60 is root 3. Okay. So root 3 minus 1 upon, I think there should be plus in the denominator. Sorry. 1 plus root 3. Now we don't have integer in the denominator. To get the integer in the denominator, you have to rationalize this. Rationalize the denominator. Okay. So the rational of the denominator is 1 minus root 3. Okay, rationalize this and you'll definitely get the denominator as integer. Okay, so this I leave it up to you. After rationalization simplified, you'll get a single integer as the denominator. Okay, let us go to question number 27. Question number 27. Now sin theta plus alpha is equal to cos theta plus alpha. Therefore, sin theta plus alpha upon cos theta plus alpha is equal to 1. Therefore, tan theta plus alpha is equal to 1. Right? So, tan A plus B formula. So, tan A plus tan B upon 1 minus tan A tan B is equal to 1. Now, cross multiply this term on the right hand side. So, tan theta plus tan alpha is equal to 1 minus tan theta tan alpha. Now, what we are supposed to prove, I'll just write it down for you. Okay, just a second. So, you're supposed to prove tan theta is equal to 1 minus tan alpha upon 1 plus tan alpha. So, we need to have tan theta as a separate term in the left hand side. So, I'm underlining all tan theta terms. So, these terms which I have underlined, tan theta term, I'll keep it on the left hand side. So, tan theta minus tan theta tan alpha. And the terms which don't have tan theta, I'll group them and I'll keep it on the right hand side. So 1 minus tan alpha. So left hand side take tan theta common, 1 minus tan alpha. Okay, now you can cross multiply. Okay, I think something somewhere has gone wrong. Let me check. 1 minus tan alpha. Yeah, so guys, this term, if it is going on the left hand side, they should be positive. Okay, they should be negative. Sorry, yeah, upon 1 plus tan alpha. So this is what is required and important. Fine. So that was your question number 27. Let's go to question number 21. Okay. So left hand side I'll start with 1 plus tan theta, tan 2 theta, sec 2 theta, tan 2 theta, tan theta, sorry. And your RHS is sec 2 theta. We need to prove this is equal to sec 2 theta. So 1 plus sin 2 theta upon cos 2 theta, sin theta upon cos theta. Okay. So this you take LCM, cos theta, cos 2 theta, cos theta plus sin 2 theta, sin theta upon cos 2 theta, cos theta. So this is A, this is B, this is A, and this is B. So this is equal to cos A cos B plus sin A sin B, that is cos A minus B. Okay. So cos 2 theta minus theta. Fine. Upon cos 2 theta, cos theta. So what is cos 2 theta minus cos theta? It is cos theta upon cos 2 theta into cos theta. So this is getting cancelled. You can send cos theta up in the numerator, it will become sec 2 theta because cos and sec are reciprocals of each other. Fine. Okay. So that was your question number 21. Fine. Let us go to question number. I suppose I should solve question number 20 right now. 20. Okay. So they have given sine alpha plus beta is equal to 4 by 5. Okay. And sine alpha minus beta. Okay, this value is also given, and that is 5 by 13. And alpha plus beta and alpha minus beta are acute angles. So remember one thing, alpha minus beta are in first quadrant. So now cos square alpha plus beta is equal to 1 minus sine square alpha plus beta. You can also use triangle method, not a problem. Okay. So 1 minus 4 by 5 the whole square. So 1 minus 16 by 25. Okay, that is equal to 9 by 25. So sine cos alpha plus beta is equal to, this is square, this is cos square. So cos will be 3 by 5. And definitely it is going to be positive because alpha plus beta is in the first part. Okay. So we got the value of cos alpha plus beta from sine alpha plus beta. Okay. Next, sine alpha minus beta. Sine alpha minus beta is, I think, 5 by 13. So cos square theta. So cos square alpha minus beta is equal to 1 minus sine square. These are fundamental identities. So 1 minus 5 by 13 the whole square. 1 minus 25 by 169, which is equal to 144 by 169. So this is cos square. So cos alpha minus beta will be 12 upon 13. And this also will be positive because alpha plus beta and alpha minus beta both are in first quadrant. Right? So we got these values. Now we need to prove that tan 2 alpha is equal to 63 upon 16. Okay. Now here I'm just writing tan alpha plus beta also. Tan alpha plus beta is equal to sine upon cos. This upon this. So this will be 4 by 3. And here tan alpha minus beta. Tan alpha minus beta will be sine upon cos. So this upon this, which will be 5 upon 12. Okay. Now we need to prove tan 2 alpha is equal to 63 upon 16. Now tan 2 alpha can be written as tan alpha plus alpha, which can be further written as add beta and subtract beta. Okay. So this is tan alpha plus beta plus tan alpha minus beta. Okay. So this is A and this is B. So tan A plus tan B, 1 minus tan A tan B. So tan A is alpha plus beta plus tan B. Tan B is alpha minus beta, tan alpha minus beta. 1 minus tan. Put the values of A and B, I mean. Now please substitute the values of this individual values you can substitute. Okay, this individual values we can substitute because we have calculated those values. Okay, those values we have calculated. Put these values and check what is the answer. Okay, so you have to solve, put the values, solve, simplify, and get the answer. So that's not a very difficult task for you guys. Just verify whether the answer is 63 by 16. Okay, that was your question number 20. Yeah, 20, correct. Fine. Solving question number 19 right now. Question number 19. They have given tan A plus B is equal to X, and they also have given tan B is equal to half. Okay. So tan A plus B is tan A plus tan B 1 minus tan A tan B is equal to X. So tan A plus half 1 minus tan A into half, right? I think I'm copying correctly. Yes, 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 correct. On the left hand side, take LCM. Okay, so the next step I'm writing over here 2 tan A plus 1 upon 2, 2 minus tan A upon 2 is equal to X. So this 2 and 2 will get cancelled. So we're left with this cross multiply 2 tan A plus 1 upon 2 upon X into, sorry, upon that term we are cross multiplying X into, I showed you the previous slide. This term I'll take it to X into 2 minus tan A. Okay. So 2 tan A minus 1, 2x minus 2 tan A, right? Now we need to find out the value of tan A. So I'm taking all tan terms together. 2 tan A plus, just a second, I need to check whether I've copied correctly. This is plus, sorry, I've written minus. So this is plus over here, and this will be 2x minus x tan A. I'm sorry, x into tan x is x tan A. Okay. So the take that x tan A term on the left hand side, x tan, and this will be 2x minus 1. Take this two terms together, which does not have tan A. Okay. So tan A into 2 plus x is equal to 2x minus 1. Therefore, tan A is equal to 2x minus 1 upon 2 plus x. Fine. So this is your answer. They wanted tan A to be uh, proved to be 2x minus 1 upon x plus 2. So that is what we have got. 2 plus x and x plus 2 are one and the same thing. They are asking you tan A minus B terms in terms of x. Next part of the question. So tan A minus B in terms of x. So tan A minus B is tan A minus tan B, 1 minus tan A tan B. Okay. So tan B is half. And tan A we have proved now. 2x minus 1 upon x plus 2. 1 minus 2x minus 1 upon x plus 2 into half. So take LCM. 2 into 2x minus 1 into x plus 2. 2 into x plus 2. So 2 into x plus 2 minus 1 into 2x minus 1 upon 2 into x plus 1. And this is getting cancelled. Fine. So let's do a bit more simplification. Open the brackets. 4x minus 2 minus 1 minus x minus 2 minus x minus 2 upon 2x plus 4 minus 2x plus 1. Okay, so 2x and 2x is gone. In the numerator it is 5x minus 9. Denominator it is, just a second, this is 2x minus 1 into x plus 2. So 4x minus 2 minus x minus 2. And this will be 2 into x plus 2 minus. Okay. So 2x plus 4. I think there is some error that I have done. Not able to locate that. Just a second. So 2 into 2x minus 1 minus 1 into x plus 2. That is 4x minus 2 minus x minus 2. And down it is 2 into x plus 2 minus 1 into 2x minus 1. 2x plus 4. Okay. So numerator is 3x minus 4. That's for sure. Not very sure of the denominator that I'm getting. Uh, tan A is 2x minus 1 upon x plus 2. That is what we proved. Yeah. Sorry, I copied the formula wrong actually. This should be plus over here. Very sorry for this. Okay. And so these things happen sometimes while copying, while writing the steps. Sorry for that. Okay. So down it will be 4x minus 3. So it will be 3x minus 4 tan A minus B, 3x minus 4 upon 4x minus 3. Okay, 4x plus 3, sorry. Mm, 4 minus 1 is plus 3. So we got the value of tan A minus B in terms of x as required. Now they are saying tan A minus B is 1 by 3 and A is acute. Now we got the value of tan A minus B. This is 3x minus 4 upon 4x minus 3. Now they are also saying tan A minus B is 1 by 3. So this value is 1 by 3 and the value of A is acute. A is in the first quadrant. Okay, so we need to find out A. Okay, so solve this, you'll get a certain value of x, right? That value of x you're going to put where? This value of x, you put it over here. Tan A is equal to 2x minus 1 upon x plus 2. Okay, यहाँ पर डाल दो उसका value and check what is the value you're getting. If you're getting tan A is equal to, let's suppose if you're getting 1, so it is 45 degrees. If you're getting tan A is equal to root 3, then A is 60 degrees. If tan A is equal to 1 by root 3, it is 30 degrees. Okay, that is how you have to solve this further. So that was question number 19, I should say. That is also done. Okay, so this was session number 1 on exercise 5A. Soon I will be uploading session number 2. Thank you.